So in the last video, we have seen about the process of thermal decomposition and also photolytic decomposition. So let us quickly understand about the other types of decompositions. So decomposition with the help of electricity is called as electrolytic decomposition, or simply it can be called as electrolysis. So this is a very good example. The decomposition of water in the presence of electricity is a very good example for the electrolytic decomposition. So what is happening during electrolysis of water? Water, when it is subjected to electric current, it will get decomposed into hydrogen gas and oxygen gas in the presence of dilute sulfuric acid. So this is how electrolysis of water takes place, releasing hydrogen and oxygen gas. So let us see a simple setup to understand how electrolysis will take place. So take a plastic mug and make two holes, insert two graphite rods. You can see these are the graphite rods which will act as electrodes. You know, electrodes, they help in conducting the electricity from the source, that is the battery here. And actually graphite rods that are there, they are made up of carbon, and these are actually inert in nature. They won't cause any reaction. They won't react with any of the substances, and moreover, they are better conductors of electricity. So that's why we are using graphite rods as the electrodes here. So we have taken a plastic mug, we have made two perforations, and we have inserted the graphite rods there, and a small rubber stopper is placed near the holes, and the electrical connection is given to a 6-volt battery there. And we have taken water till half of the mug, and we have taken two test tubes with water and inverted them on the electrodes. Among the electrodes, one is anode, which is positively charged, another one is cathode, which will be negatively charged. So this is how our setup will be made. And once the electric current, the switch is here, so once the electric current is established, electrolysis will take place. So here we have used dilute sulfuric acid. So few drops of dilute sulfuric acid also you need to add into water. What is the purpose of dilute sulfuric acid is, dilute sulfuric acid helps in better electrical conductivity. So pure water that is used for electrolysis will have few ions for electrical conductivity. So the conductivity increases upon adding dilute sulfuric acid, which will dissociate into hydrogen and sulfate ions and electrical conductivity. So that is the purpose of dilute sulfuric acid being added here. So we are adding dilute sulfuric acid into water as such, and when electrical connections are given, after a period of time, you see that the water in these test tubes, they are displaced downwards because of formation of the gas. So near the anode electrode on that, the test tube that is inverted, here a gas will be collected, and near the cathode, the test tube that is inverted on the electrode, which is cathode, there also a gas will be displacing the volume of water there. So you can check what are these gases actually. So when you take out the test tube and when you insert a burning splinter there, the splinter will burn with more light, that is more vigorously. That indicates that here the released gas is oxygen gas. So oxygen is negatively charged, so it will get deposited near the positively charged electrode, that is the anode, and the other side you have the deposition of the gas. That gas, what it is, you can check as hydrogen gas. If you introduce a burning splinter, it will put off with a pop sound, so that indicates that the gas is hydrogen there. So oxygen gets deposited towards the anode, and cathode side you have the deposition of the hydrogen gas. Actually, the ratio of hydrogen and oxygen gas that are getting deposited is 2:1. That is, hydrogen gas is more in proportion compared to oxygen, because water molecules contain two hydrogens. In the formula it is H2O, that is more of hydrogen is present. That's why the ratio also will be 2:1. So these are the details what you have to know. What is the importance of sulfuric acid here, and why graphite is used, because it is inert in nature, and the other details like this. And this is how the experiment will be done, wherein electrolysis will take place, and we have the depositions of the gases, that is hydrogen and oxygen, in the ratio of 2:1. This is how electrolysis can be explained simply. So let us talk about the catalytic decomposition, wherein catalyst is an agent which will fasten up the reaction. It will help in easy breakup of the compound into simpler substances. So here you can see H2O2. That is, what is H2O2? By the way, it is hydrogen peroxide. Hydrogen peroxide in the home also, if at all you are wounded, you will be commonly using hydrogen peroxide, which is an antiseptic. So this hydrogen peroxide in the presence of yeast, Yeast contains the enzyme which is called catalase. So this catalase enzyme actually, okay, is a catalyst which will break down hydrogen peroxide into water and oxygen. Okay, so this is what is catalytic decomposition. Okay, or it can also get broken down into water and oxygen in the presence of one more catalyst, which is manganese, okay, dioxide, MnO2. Okay, likewise we have is okay, 2O3, and this in the presence of manganese dioxide will form oxygen. You know what is O3? O3 is nothing but it is ozone. So ozone is not suitable for us to breathe in. So for air purification in atmospheric chemistry, they will be using manganese dioxide for air purification in atmospheric chemistry. This is very useful application actually. In the presence of catalyst, it gets decomposed and it will be forming oxygen, which will be easy for us to breathe in. So this can happen through catalytic decomposition. So let us see some daily life examples of decomposition reactions. So actually decomposition, okay, if you see the fruits, the solid fruit, okay, slowly it ripens and it becomes soft. So because of decomposition of complex carbohydrates into simpler ones in our daily routine. Also, okay, we use okay, baking soda for baking purposes, which is sodium bicarbonate. So this baking soda, when it is heated, it will form sodium carbonate, carbon dioxide and water. So because of this carbon dioxide gas, actually the puffing, when you eat something, it will be all puffed up. That puffing happens because of carbon dioxide that is getting released here. So this is a very good example, okay, wherein we are using the decomposition reaction in our daily life. Also, as I told you, in olden days, okay, films were there, negatives were there, which were developed into photos. Okay, so there actually silver chloride or silver bromide will be coated onto the films, and those actually they will develop the imprints when light falls on them. Okay, because of decomposition of the material that is coated on the films. So silver chloride, in the presence of sunlight, it will form silver. That's why it becomes gray. Okay, and then formation of chlorine in photography, that is useful. Even air purification can also be told as an application. Okay, and also your hydrogen peroxide, which is most commonly used in the household. Okay, that also upon long standing, it will lose its power because of exposure to light. When it gets exposed to light, when it gets exposed to heat, or when it is subjected to action of the catalyst, it will lose its power because it will get decomposed into water and oxygen. So its antiseptic power will be lost due to different reasons. That's why hydrogen peroxide usually will be stored in dark colored bottles called the amber colored bottles to protect them from sunlight particularly. So like this, we have some daily applications, and these are all the different types of decomposition reactions what we have. Okay, so hope you have followed.